Good morning.
Morning, sir.
Good morning. Good morning. So I hope you all received the slides yesterday itself, right?
Yes.
Good then. So did you guys revise? Did you all revise?
Yes, sir.
Oh, good. Right then. So usual, let me ask some questions related to continental drift theory. Okay. Okay. So shall I start the question?
Yes, sir.
Okay. Which of the following evidences were proposed by Alfred Wegener? Which of the following evidences were proposed by Alfred Wegener in support of the theory of continental drift? Okay, so you have to tell the proposals that were made, the evidences that were proposed by Alfred Wegener. Okay, so first statement is matching of the shorelines of continents. First statement is matching of the shorelines of the continents. This is the first evidence. Second is ancient rocks of Brazil coast matches with those from the Eastern Africa. Okay, ancient rocks of Brazil coast matches with those from Eastern Africa. So this is second point. Third statement is presence of tillite and placer deposits across continents. Presence of tillite and placer deposits across continents. Okay, this is the third statement. And fourth statement is distribution of fossils. This is the fourth statement. Okay, so your options are 1, 3, and 4 only, 1, 2, and 3 only, 2 and 3 only, and all the above.
All the above?
All the above.
3, 4.
Okay.
1, 3, 4.
1, 3, 4. Okay.
Sir, 1, 3, 4.
1, 3, 4. Okay. So people who said all the above, why did you guys choose all the above?
So what was the third statement?
Third statement was presence of tillite and placer deposits across continents. That is the third statement. So people who chose all the above, why did you go for all the above? Am I audible?
Yes, sir.
Okay, good then. So people who chose all the above, kindly tell me. Right. So people who chose all the above, keep thinking. Before that, I'll go to those people who said 1, 3, and 4 only. Okay, so since majority of the people said 1, 3, and 4, I'm going for that. So guys, what is wrong with the second statement? Africa, western side, it is not east. I think the rocks from Western Africa are not from the east. Okay, so that's what. Okay, so that is what exactly the answer is. Because the rocks are from western part, not on the eastern part. Good. Right. So right. Alfred Wegener proposed which of the following forces to be responsible for continental drift? Okay, question is Alfred Wegener proposed which of the following forces to be responsible for continental drift? Okay, first statement is rotation of Earth. Okay, first statement is rotation of Earth. Second statement is tidal force of the moon. Okay, tidal force of the moon. Third statement is tidal force of the sun. Your options are 1 only, 1 and 2 only, 2 and 3 only, and all the above.
All the above.
All the above. Okay. So what is the rotation of Earth? What is the force behind the rotation of Earth? Or what is precisely the name of the force created by rotation of Earth?
So polar fleeing force.
Centripetal.
Good, polar fleeing force. Okay, or centrifugal force, no issues. You can say both. Okay, good. Right, okay. Right. So what you guys do is now I'll give you a mains question related to continental drift theory. So take some 10 minutes. Okay, not more than that. Okay, just 10 minutes. You have to complete the answer. Okay. So I'll give you a question. What you guys do is write answer for this one. Right? Shall I?
Yes, sir.
Okay. what are the evidences? What are the evidences? What are the evidences proposed by Alfred Wegener? What are the evidences proposed by Alfred Wegener to support his continental drift theory? What are the evidences proposed by Alfred Wegener to support his continental drift theory? Okay, what are the evidences proposed by Alfred Wegener to support his continental drift theory? Question mark. Okay, question mark. List the reasons. List the reasons. List the reasons on why continental drift theory. List the reasons on why continental drift theory failed to provide. List the reasons on continental drift theory, on why continental drift theory failed 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 to provide failed to provide failed to provide a solid failed to provide failed to provide a solid argument for its support. Argument for its support. Okay. So,
Okay, sir.
So this is the question. 150 words. Okay, 150 words. Take 10 minutes. Write answer for this one.
Hello, sir.
Yes.
Sir, should we explain about the evidence in support of CDT in detail or just point out?
No. First, give me the introduction.
Okay, okay, okay.
Okay. So guys, you have taken enough time, right? Shall we discuss? We shall discuss. So what is the introduction?
Sir, I think we can start by explaining what is continental drift theory.
Okay, good. Any other introductions? It is a
So-
theory that explains how continents should position on Earth's surface, and it is set forth in 1912. Okay, good, Sayuj. That's a okay. Anyone else?
So we can start with the thing about the West Asia, how the fossils are more hugely deposited in the West Asian countries.
Yes, that is a good way. But one thing you should know is it's better to directly hit the bullseye. Okay, better than beating around the bush. Directly hit the bullseye. Go for continental drift theory. Given in brief, just in 3 lines, tell what is continental drift theory. Because why I'm saying this is, I told you 150 words. Okay, in UPSC actual examination, if you are going for 150 words, UPSC will give you just 2 pages. Okay, they'll give you just 2 pages, and to write those 2 pages, you will be hardly having 6 minutes in your hand. Okay, 6 minutes, you have to fill 2 pages and 150 words. Okay, so considering that scenario, if you try to explain more, or if you try to come up with an innovative introduction, see, I'm not saying it is not good. What I'm saying is it's humanly impossible in the examination hall. So better to stick with something very basic, like how Sayuj put 1912 by Alfred Wegener. Okay, it tries to explain why continent shift, or it tries to explain why climate change has happened, or it tried to explain why continents are the way that is today. Okay, so something very basic, just 3 lines. Okay, don't go for innovative introduction or ornamental type of English. Okay, nothing is necessary. A simple introduction of 3 lines, which is filled with some facts, statistics, data, or the basic explanation of the question. You can even explain what is continental drift theory. You can give an explanation for continental drift theory in those 3 lines. You can just simply say Alfred Wegener, but in 1912, put forth this continental drift theory. Continental drift theory is so and so. Just 3 lines, not more than that. Am I clear?
Yes, sir.
Okay, good. So anyone else? Any other introduction type? No? Okay, if there is no other introduction, give me some conclusion, guys. How did you conclude the answer? Conclusion? Am I audible?
Yes, sir.
Okay, then tell me, please. Okay, that is good. Theory is a forerunner to plate tectonics and seafloor spreading, but be little more concerned about the continental drift theory also. Okay, you can say that continental drift theory failed because of not able to provide evidence on why the forces are acting in such a way, or the forces of continental drift theory is not strong enough to prove. However, the scientific community got intrigued by the continental drift theory. Okay, so you can use those kind of words where you are no, even though continental drift theory is a failed theory, it provided an impetus for the next generation of scientists to come up with a solution for Okay, come up with a solution that come up with a solution to make the continental drift theory a better version. Okay, you can go for those kind of words. You can use in such a way. Okay. Anything else? Any other conclusion? However, we cannot avoid the continental drift theory. Scientific studies with new technologies can be reopened and modify the theory. Good, Mubashir. That's one way to see. Okay, so anyways, now coming to the body of the answer. Okay, so how many of you drew diagrams? How many of you drew diagrams? Noah. Okay. See, one thing you should keep in mind for a geographic question. Okay, you have to draw diagrams. There is no way that you can explain geography without showing diagrams. There is no way you can explain geography without drawing diagrams. It's impossible, and it is not good for UPSC also. Okay, for a geography question of 10 marks, there should be 2 diagrams. For a geography question of 15 marks, there should be 3 diagrams. Okay, see, you are speaking about continental drift theory. You can just draw a small South America, a small Africa joining, jigsaw fitting. You can say that. Okay, you can speak about how the fossils are distributed throughout the world continents. You can speak about that. Okay, you can just give a diagrammatic representation for. I'm not asking all the evidences. Okay, at least some 2-3 evidences you can give diagrams. At least 2. At least for 2 evidences you can draw diagrams. Okay, if you are going to write geography answer, there should be diagram. There should be diagrams. Okay, for a 10 mark, 2 diagrams should be there. For a 15 mark, 3 diagrams should be there. Keep this in mind. Okay, and apart from that, so anyways, the body of the answer has 2 parts, right?
Yes, sir.
One is
Yes.
the evidence. What is the other one?
Why the theory fails?
Right? So listing out. So one I said, when I asked about the evidences, the other one I said you to list, right? Just list. Am I right?
Right, sir.
Okay.
Sir.
Listing means, I hope you know the meaning of listing. Listing is just simply putting in points, just simply mentioning it. That is called listing. There is no necessity for you to go in depth whenever a question asks you to list something. Okay, if they ask you to explain, or if they ask you to provide, that's a different thing. But if there is something called list, if they ask you to list, just list it. Okay, not more than that. Nothing more than that is necessary. So just
Sir,
one
we can write
single
like
line. Huh?
So we can write he uses fossil evidence to support his continental theory. That much enough?
Not getting you what?
No, list out means we can write like this. He uses fossil evidence to support his continental drift theory.
No. The second part of the question is where I asked list.
Okay, sir.
Not on the first part. Even that you can do, because anyways you are drawing 2 diagrams. If you are drawing 2 diagrams, I'm saying, if you are drawing 2 diagrams, better to stick with points. Okay, try to write geography answers using points. 1 point should not be more than 3 lines. The effective way to write points in geography answers is 1 line, 2 lines. That is better. never more than 3 lines. Okay, so it's basically an ideal point should be 1.5 lines or 2 lines, fine, but never more than 3 lines. Am I clear?
Sir,
Yes.
sir, what diagram could we draw in this question?
That's what I said. You can draw a jigsaw fitting. You can just draw a small South America continent, and adjacent to it, you can draw Africa continent, and you can show that no, the jigsaw fitting is there as it is here. It's here, right? You can just draw Africa and South America, which is very easy.
Okay, okay,
Right.
sir. Yes,
That
sir,
you can
understood.
draw. You can say about this botanical evidence. You can say that rocks on the either side of the coastal regions are of same age, same composition. You can say, right? So you can give 2 diagrams definitely for this question. Leave 2 diagrams. There are people who will draw diagrams for all the evidences here. Okay, am I clear?
Yes, sir, understood.
Okay, then fine. So shall we move forward?
Yes,
Yes,
sir.
sir.
Okay, good. So now, anyways, you know that continental drift theory failed. Continental drift theory failed to provide the evidences, the strong arguments for why the continents drifted away. Okay, so there has to be a force which drive these continents to drift away from each other, right? So in the year 1930, first time someone tried to come up with a theory that really explained or that formed the core of explaining why continents drifted away from each other. Okay, in 1930 by Arthur Holmes. Arthur Holmes spoke about something called convection current theory or convection current in the mantle. Okay, am I clear?
Clear, sir.
Okay, so how many of you people boil water? That is the simplest form of cooking. How many of you people have boiled water?
Yes, sir.
Yes, sir.
Okay, good. Right. So then you all must be knowing about convection current theory. It's very simple. If you boil water and keep it closed with a lid, okay, while boiling, what happens? What happens while boiling?
So vaporization.
Okay, good. Then,
The lid start to move.
why?
Due to pressure.
Lid starts to move, but why?
So due to high pressure.
Vapor pressure.
High pressure, vapor pressure. Okay, right. Okay. If you take the lid, okay, if you take out the lid and see what's happening on the surface, what do you usually found on the surface of the water when water is boiling?
Bubbles.
So bubbles came out.
Bubbles, right? And if you throw something into water, okay, any material, anything that if you throw in the water inside the water while it is boiling, you can see the movement of whatever you throw inside. For example, if you throw leaves, okay, for example, people who make green tea from the the crude green leaves, okay, you people might be knowing, if you throw it in a boiling water, upward movement will happen. Am I right? And after coming up, what will happen is it will again go down. Again it will come up. Again it will go down. Am I right?
Right, sir.
Yes, sir.
This is the convection current. Okay. So it's basically water boiling concept, nothing else. Right? So this is the container and water is there boiling, what will happen is a bubble will be created, bubbles on the top. So bubbles will move like this. Okay, if you see, bubbles will move like this, right? You can see center and bubbles moving on the sides of the center. Am I right?
Right, sir.
So if you throw something, it will go down, again it will come up, it will go down. So right, it will go up, it will go down, it will go up, it will go down, it will go up, down. Okay, so this is what happens with convection current. So basically, convection current is what we do when we boil water. Okay, so this is the convection current. Okay, is it visible here? This is the mantle portion. You know, different layers of earth is there. We have lithosphere, we have asthenosphere, we have mantle, we have core, outer core, inner core, upper mantle, lower mantle. So different regions are there. Don't worry, we'll see this in earthquake. When we see about earthquake, how we find different layers of there, then we'll see all those things. Okay, now it is not necessary. Now just concentrate on the important thing, that is the convection current, right? So this is what I was saying. If you boil water, what will happen is this kind of upward and downward movement. So this is basically the boiling portion where you will see the bubbles. Okay, so now if you consider the lid that you put on your that you put above your boiling water, that is what the lithosphere is actually. Okay, the lithosphere of earth is basically the lid that you put upon your what is that, water, boiling water, the container. Okay, so what happens is the pressure, the convection current that is created, it makes the lid to shake. Okay, and it makes the continents to drift away from each other, right? So wherever a weak link is there, see, obviously it cannot happen at all the points, right? For example, if a place is this thick and another place where the thickness is low and again thickness is high, which means wherever the weakness is there, wherever the thickness is low, this is where eruption can happen. Am I right?
Yes, sir.
If pressure is built over a period of time, what will happen is wherever a weak link is there, for example, simple pressure cooker concept. Okay, pressure cooker was able to move the whistle on the top because that is the weak link. All other regions of pressure cooker on the top, the lid of the pressure cooker is closed and tight, whereas the whistle is the only part where the weakness is there. And just like that, wherever weakness is there, you can see the break happening. Okay, am I clear?
Yes, sir.
For that, you should have a little more understanding why it is weak in certain region and why it is strong in certain regions. Okay, so usually the sea, okay, the sea floor is weaker compared to the continental floor. Okay, the sea floor is weaker than the continental floor. The reason is continent consists of mountains, hills. What is ocean basically? How oceans are created? We saw evolution of earth. How oceans are created?
Continuous rainfall.
Continuous rainfall. Okay, where did they go? Continuous rainfall. Where the rainfall went? What was the place? Where did the rainfall go? The continuous rainfall for millions of years together. Where did they settle? Exactly. Depressions. Depressions are basically what? A place where depressions are the place where actually a small crater kind of is created. See, for example, if you consider this to be the continental floor, okay, and wherever depressions are there, water stayed there. Okay, so if you see the thickness of the floor, this could be the thickness of the floor. Okay, so depressions means less amount of or less land availability. Okay, or lithosphere is thin in that particular region. Okay, so basically that is the weak spot. Am I right?
Right, sir.
So this is where mid-oceanic ridges comes to play. So mid-oceanic ridges are those places where eruption happens. Mid-oceanic ridges are those places where the drifting of continents happens. Mid-oceanic ridges are those regions where new land is formed through eruption of lava, right? So this convection current is created in the asthenosphere and mantle region of the earth layer. Okay, so basically if you see the earth, it has different layers. As I said, lithosphere is there. After lithosphere you have asthenosphere. Asthenosphere is basically a plastic medium. Okay, it's a semi-solid, semi-liquid plastic medium, and and below that mantle, we have mantle. Okay, we'll see all those things, why it is plastic. Okay, different with the concepts we'll see later, but right now if you understand this much, it would be enough. Okay, so what happens is in this ridge region, break of continent happens. After breaking, eruption will create new land. Okay, so what is Newton's third law?
For every action, equal and opposite reaction.
Exactly, there will be another reaction. If new land is created in one region, that means old land should be destroyed in another region, right? If new land is created in one region, old land should be destroyed. Am I right?
Yes.
Why? Because where is the source? Where is the source for pressure? How will you get a source for pressure? How will you get source for eruption of lava? See, lava is not a source which which is replenishable. Okay, it will be replenishable, or it's replenishable because only when the old land is destroyed and it comes under the hot magma that is inside the earth layer. Okay, so what happens is in another zone, the old lands get submerged inside the mantle, and thereby, since the mantle is already hot, it does what? Since the magma, the mantle region is already hot, since the asthenosphere region is already hot, what happens in that region when the old land gets inside? When the old land gets inside, what happens? Hmm? What happened? What happens in such scenarios? Guys, come on, fast. You understand my question? Yes, that is correct, Arjun. Okay, so what happens is once this lithosphere, the old land, gets destroyed and submerges, okay, subduction happens, it becomes a part of the mantle itself. It gets molted. Okay, after melting, what happens is it becomes a molten lava, and the molten lava becomes a part of the mantle itself. And again, what happens is eruption will happen. So one region eruption happens, new land is created. The other region subduction happens, and old land would be destroyed. So this is like a cyclic process. Is it clear? Is it clear?
Yes.
Okay. So now my question is, where do the heat come from? Where is the heat coming from? We know that mantle is hot, okay, but new old land is destroyed and getting inside, right? So that means over a period of time, what should happen is the mantle should lose its hotness, right? So where the heat is coming from? Core. Oh. So I'll give you some example in a way which you will understand. If you are boiling water, okay, and adding more and more cold water into the hot water without heating it, then the hot water become cold, right, over a period of time. Is that
Yes.
right?
Yes, sir.
Yes. So which means there's a source to heat the old land that is getting inside, or there's a source that is heating the mantle. So what is the source? Where is the source? Which is the source? See, Arjun is asking a question, good question. What is the source of heat in core? Because people said core is the answer, core is the source. Then what is the source for core? What is the source of heat in core? There should be a source, right? Am I right?
Yes, sir.
Even if heat is coming from core, as some people said, that should have a source. The source is radioactive materials that are there in the earth. Okay, so core is not the source for convection current. Core is not the source for the heat. It is the radioactive materials that are there in the earth is the source for heat, for mantle also, for asthenosphere also, for core also. Am I clear? So
Yes,
the
clear.
radioactive materials that there are in the earth is continuously providing the source of heat for the mantle, for the earth. Okay, this is what convection current theory says. So do we have an answer now why continents are drifting away from each other? Do we have a force that is responsible for making continents to drift away from each other? Do we have a solution now? Do we have an answer now?
Yes.
Yes. Okay, so this is what I said. According to this theory, the intense heat generated by radioactive substance in the mantle seeks a path to escape and gives rise to the formation of convection currents in the mantle. So wherever rising limbs of these currents meet, oceanic ridges are formed on the seafloor due to the divergence of lithospheric plates, or known as tectonic plates. Okay, so this is what called as convection current theory. Am I clear? Shall we move forward?
Yes, sir.
Okay. So my question is, when was the first time someone came up with a theory like continental drift theory? What is the period of continental drift theory?
1922.
1922.
22.
Okay, good. But Biju is saying it's 1912, which is right. Which is right.
Alfred Wegener found it in 1912. No,
Hmm. (1922). Okay, so 1922 someone came up with a theory. Then in 1930 someone found the reason for it. Okay, why it happened. Then someone found a little later something called paleomagnets. Okay, and just a little later there came a concept called seafloor spreading. Okay, it all happened the period between World War I and World War II. Why the scientific community so keenly started to notice how Earth is situated, how the different layers of Earth are there, and what is the reason or how the sea is there? Why? Why suddenly? That just in a span of 30 years. Just in a span of 30 years, all the important theories came. And if you consider the plate tectonics also, that is just in a span of 40 years done. 40 to 50 years, the entire theory about different things that makes the earth move, the endogenic force, the exogenic force, the seafloor spreading, paleomagnetism, so many things came up just in a span of 50 years, and that too especially between world wars. Why? So people who are there in my world history class, tell me.
Scientific advancement, something like that.
Okay, scientific advancement. Maybe so many scientific discoveries happening to find solutions. Okay, but why scientific discoveries are happening only during this period? Or a lot of scientific discoveries happen during this period?
Revolutions.
Revolution, I mean industrial revolution.
No, total change happening in a sectors.
That's what industrial revolution, right? Is that what you are saying? To show which country is better than others, competition. Okay. See, basically, Germans, okay, Germans, Brits, all they wanted was to fight war to prove their supremacy. Okay, so the answers that you are given is not bad. Okay, that is also a valid reason only. But the most important reason is all of them wanted to fight war and all of them wanted to show the supremacy and to show which country is the strongest to the world. What they did was they went into a race or they wanted to find a solution. They wanted to know how actually the sea is because they want to send ships. Okay, And not just ships. Even in ships, there are different types of ships, right? Is there any ship that go under sea, under ocean?
Submarines.
Submarines. Without knowing the oceans, how can you send submarines? How can you fight war? Right? So what they did was they sent scientists down the ocean. They wanted to see how the ocean is, how submarines can be developed. So those scientists who went down, they suddenly found that there are mountains inside the ocean. There are volcanoes inside the oceans. So far, the world did not know anything about mountains and trenches, ridges, abyssal plain, nothing. They knew nothing about the oceans. All they thought was oceans are just like lakes, but in bigger size, which means they did not know that there was features inside the ocean. All they knew was, all they thought was, it is a vast plain full of water. That's what they thought. Only after going inside, only after wanting to send submarines, only during the war period, they started analyzing the ocean, analyzing the undersea, under ocean regions, and then they found different features are present inside the ocean. And that's how people started to question various things. And that's how scientific discoveries related to all the features of the oceans, the concepts like seafloor spreading, the concepts like paleomagnetism, the concepts like convection current, all happened only because of war. So war is good, right? War is good, right? No war. No bullshit. Just now we saw so many good things happened because of war. Losses too. Okay. And people who know better, but at what cost? Yes, that is good. Has its positive and negative. Yeah, anything that you take in this world will be having both the sides, the positive side as well as negative side. No matter what the issue is, both the sides you can present for anything. This is what you should be keen in providing to UPSC. This is what you should be keen in providing an answer in UPSC exam. So whenever you are expected an answer in UPSC exam, whenever there is a question, wherever there is a question, you should always see both the sides of the coin, both the sides of the answer. Only then you will be able to comprehensively address the question asked. Okay, no matter what the question is, no matter how absurd or no matter how difficult it seems, there is always two sides. Okay, and also war is the reason why Japan was able to shine better, why Japan was able to build back better. And war is the reason why all the Western nations that we see today is full of democracy. War is the reason why the Western nations, as we see today, got developed. War is the reason why the cutting edge technologies of Western countries are present today. Okay, and not just the World War One and Two, even the Cold War. Cold War is the reason why we have satellites today. Cold War is the reason why our telecommunication lines became so strong today. Cold War is the reason why we are able to know more and more about the universe, more about the galaxies, more about the stars. Okay, basically the space war, the willingness or the competition between USSR and USA was the reason why we have such a advanced space programs these days. Okay, so if you say war is altogether wrong, that is also wrong. If you say war is good, also wrong. Okay, always try to strike a balance between good and bad. Am I clear? Shall we move forward?
Yes, sir.
Okay, right. So next concept is paleomagnetism. Okay, so basically paleomagnetism is again a simple concept, just like convection current, but paleomagnetism is one of the reasons why we have a strong understanding about the earth. Okay, a small concept, just like convection current theory, a small concept, but it gave a renewed spirit for the entire continental drift theory. Okay, if it is not convection current theory, then seafloor spreading concept wouldn't be there. If there is no convection current theory and seafloor spreading, plate tectonics theory won't be there. If there is no plate tectonics theory, we still till today we won't know anything about how mountains are formed, how volcanic activities are existing. Okay, so one leads to another. Even though the concepts are small, it's very important and it's an integral part of what we know today as the world exists. Okay, so paleomagnetism is a simple concept, as I said. It is just the study of Earth magnetic field. Okay, or to be precise, it's just the study of record of Earth's magnetic field, which means paleo. You know the meaning of paleo, right? What is paleo? Paleolithic, paleo diet. What is paleo?
Old age.
Simple, paleo means old. Paleomagnetism means what? Old magnetism, which means how the Earth magnetic field was there billion years ago, how the Earth's magnetic field was there some 10,000 years ago, how Earth's magnetic field was different some 2 million years ago or 3 billion years ago. Okay, so finding the record of how different the Earth's magnetic field is called the paleomagnetism, basically. Okay, you understand? Is it clear?
Yes, sir.
Okay, so what people or what the scientific community uses, they use the records such as the rocks, they use sediments, they use archaeological remains, archaeological materials to find how Earth's magnetic field was different in different ages during different ages. Okay, and by going through the record, what scientific community found was the Earth's magnetic field, okay, is reversible in nature. Okay, that is, as I said the other day, where is North Magnetic Pole? Where is North Magnetic Pole? Canada, Ellesmere Island of Canada, which is far away from the 90-degree North Pole. Okay, so scientific community found that the magnetic field, Earth's North Pole, South Pole region, the polar regions of Earth magnetic field and the Earth's magnetic field are changing, and that the current day South Pole was once in the North Pole. The current day North Pole was once in the South Pole. Okay, after studying rocks of different ages, what they found is the poles are reversible in nature, which means after millions and millions years later, the North Pole of today, that is the current magnetic North Pole, which is there in Ellesmere Island, it would be there in Antarctica. And the current South Pole, which is in Antarctica, would be there in Russia. Cool, right? So Earth's magnetic pole, the Earth's magnet is shifting, is wandering around, is reversible in nature. Okay, anyways, we won't be there to see the reversal, but this is what they found because of, this is what they found in paleomagnetic studies. Okay, so how is this going to help us? How is this going to help us? How is this going to help us?
Explorations.
Explorations. Okay. Then then age of Earth. Okay, good. Yes, that can be found. Then what else? Anjana, concentrate on the class. The question is, what is the use of paleomagnetic studies? What are we going to gain from paleomagnetic studies? How is paleomagnetic studies is going to help us? That is what the question is. Characteristics of different minerals are. No, Arjun. To predict what? To predict what, Anantu? Species are. What species? Guys, you can think outside the box, but don't think outside the question, outside the syllabus. To know more about Earth's magnetic field. Yes, good. You can understand more about the Earth's magnetic field. By understanding more about Earth's magnetic field, you can understand more about the tectonic theory. By understanding more about the Earth's magnetic field, you can understand more about how the lithosphere is moving and why it is moving. By knowing more about the Earth's magnetic field, you can predict, okay, but you can predict what? You can predict how different the continent will be after some 10-15 million years later. And you can also predict how the continents were some 2 billion years ago or some 500 million years ago. Okay, you can predict the past also, you can predict the future also. Okay, so you can understand more about Earth's continents and oceans by studying the paleomagnetic theory, paleomagnetism. Okay, and basically this paleomagnetism came or led to the revival of continental drift theory and the seafloor spreading concept. Okay, we'll see the seafloor spreading next. Okay, so it basically I said about ridges, right? What is a ridge? What is a ridge basically? What is a ridge? We saw in convection current, right? What is ridge? What happens in the ridge?
Elevated surface.
It's a weak point, it's a gap between two plates. Okay, what happens there? What happens there? It's a gap, right? I accept that. Weak point, yes, that is correct. Lava may come out. Lava is coming out. Okay, so if you see the oceanic ridges, the mid-oceanic ridges, that is where new land is built. Okay, that is where the new land is built, which means The lava eruption makes the sea floor to spread. Okay, new land is created, which means some million years ago, the land that we see today wouldn't be existing, right? Am I right?
Yes, sir.
So, what scientific community did was they measured the magnetic field, they measured the magnetic properties on either side of the mid-oceanic ridges. Right? Am I clear? Considering this to the mid-oceanic ridge region, okay, so this is where eruption is happening, considering this region. So, on either side, okay, they started measuring the magnetic properties. Okay, so consider this as 1, this as 2, this as 3, then 4, and so on. Okay, so the properties of 1, that is the property of the land that is created on the same time, they had different magnetic property. Okay, and the land is created before that, which I denoted here as 2, here and here, they had the same magnetic property. And the land that is 3, which is got created even before that, okay, they both had same magnetic properties. Okay, but the magnetic properties of 1 is different from 2, the magnetic properties of 2 is different from 3, the magnetic properties of 3 is different from 4, and the 3 is different from 2, 2 is different from 1. So I hope you can understand. Right? Is it clear?
Yes, sir.
So the change in magnetic properties, the paleomagnetism studies proved that the sea floor is spreading. Okay, by proving that sea floor is spreading, they proved that plates are moving, drifting away from each other. By proving that plates are moving from each other, they are able to ascertain that continents are drifting. Then later they found out it's not actually the continents, it's the plate that are moving, not the continents as such. Okay, so the paleomagnetic studies of the rocks on the either side of the mid-oceanic ridges, okay, it proved the concept of sea floor spreading. Am I clear?
Yes, sir. Clear.
So one on both the sides is different. I mean, they both have same properties, different from 2 and 2 has the same properties, different from 3 and 1. So this is how it is. Okay. So sea floor spreading concept is proved, and tectonic plates concept is evolving because of the paleomagnetic studies. Okay. Am I clear? Shall we move forward? Am I clear? Shall we move forward?
Yes, sir.
Yes, sir.
Okay. So someone read the third statement given here. Third point.
Rising magma assumes the polarity of Earth's geomagnetic field at the time before it solidifies on the oceanic crust.
Okay, what is the meaning of this, guys? Rising magma assumes the polarity of Earth's geomagnetic field at the time before it solidifies on the oceanic crust. What is the meaning of that? What is the meaning of that? Thus, we get the magnetic field of Earth at the time. It's simple as that. Again, consider this to be the mid-oceanic ridge. Vent is there. Okay, vent is there, and which means magma is erupting. Magma erupting, creating magma erupts and creates a land. Okay, so this process takes some million years. Okay, so before this magma that is erupted from the mid-oceanic ridges, before it solidifies and becomes a new land, it assumes the properties of the magnetic field of that day, of that period, Earth magnetic poles. You understand? The South Pole, North Pole. Okay. So the Earth's magnetic poles are different in different periods. If that is correct, the period of one on the both the sides, the magnetic properties based upon the magnetic pole of the Earth is different from the adjacent oceanic region. Am I right? Is it clear?
Clear, sir.
So this is created at different period and this is created at different period. So what happens is, if you consider the period of both the ones are created, the North Pole and the South Pole, consider this one. Okay, the globe, this is where North Pole and South Pole was there. Okay, and during the period of second, South Pole, South Pole and North Pole. South Pole, North Pole. So next, third, North Pole, South Pole. Okay, you understand now? So alternate stripes of land that is away from the mid-oceanic ridges have alternate properties of magnetism. You understand? One, the either side, okay, one is recorded with north and south. Either side, two is recorded with south and north. Either side, three is recorded with north and south. Is it clear?
Yes.
Shall we move forward?
Yes, sir.
So this concept is, again, as I said, these concepts which we studied yesterday, today, these are highly sublime in nature. Unless you revise it, you will forget it. So kindly revise this as soon as possible. Okay, so this is what I was discussing all this time. The current magnetic, but before that, it used to be like this. So this is what continuously the red goes to other side, blue comes to this side. Okay, so all through different ages, different periods, Earth's magnetic poles are shifting. Earth's magnetic poles are reversal. Okay, wandering around. Am I clear? Shall we move forward?
Yes.
Okay, so you guys go for a break and come back. Next, we'll see seafloor spreading and plate tectonics concept. Okay. Hello all. Am I audible?
Yes, sir.
Okay. So the next important concept is sea floor spreading. So you already know the basic about the sea floor spreading, right? So now tell me, what do you understood? Okay, what did you understand from the concept of sea floor spreading, or what have you understood so far related to sea floor spreading? Tell me. What is your understanding about the sea floor spreading so far?
When the plates move, the magma comes out and forms new land.
Okay, good. Anyone else? Anything else? What did you understand so far related to sea floor spreading? Come on, guys. What happened to you all? Only one person is answering.
Sir, the chat is disabled.
Is it?
Yes, sir.
How to enable this one? Okay, now it is enabled. Tell
Okay,
me.
sir.
Hey, instead of chatting, you can just tell me, right?
So at the ridges there would be younger rocks.
Not getting what?
Near the ridges there would be younger rocks that older ones would move away.
Ah,
Younger ones would.
okay, good. Yes. Then what else? What did you understand from this concept of sea floor spreading? What else did you understand?
So it is like pushing all the landmass from the sea floor, and land formation will take place by gradual rising.
Good, very good. Yes.
So in comparing it to tectonic plate theory, where it is moving of landmass which causes breakdown, here it is a breakdown with gradual spreading out as well.
Yes. Good. So plate tectonics is basically something that encompasses all these things. Okay, but see, plate tectonics is not just a single concept. As I said, plate tectonics includes sea floor spreading. Plate tectonics include paleomagnetism. It includes continental drift theory. It encompasses everything that we have known, that we have studied so far. So we can say that plate tectonics is a solidification of all the knowledge that we gained about the how interior of the earth, or how we are not interior of the earth, how the surface of earth is evolved or evolving. Okay, so it's basically understanding about the surface of the earth. Okay, everything that is related to it. But sea floor concept is one concept only. It speaks only about sea floor spread. Paleomagnetism is all about paleomagnetism, how magnetic events have occurred, how magnet is different, how poles are different during different period, different epoch, different era. So each of these concepts, continental drift theory doesn't concern itself with anything else. It speaks only about continental drift. Why continents drift? How continents are drifting? Okay. Whereas plate tectonics is one concept which encompasses or solidified all the knowledge that we have gained through time. Okay, right. So coming back to seafloor spreading, what else? Which is the largest ocean in the world? Which is the largest ocean in the world?
Pacific.
Now, now it is Pacific, but Atlantic Ocean size is bigger
Okay.
after millions of years.
Yes, now it is Pacific, and after millions of years, definitely this place. I'm sorry, it's going to be Atlantic Ocean, which will be the biggest ocean of the world. I hope I said this right while discussing map, while we were reading map. Did I say this?
Yes, sir. You
Yes.
said that.
Yes, and the answer lies here. Why and how is because of seafloor spreading. Atlantic Ocean is becoming bigger day by day, and the reason is, and the answer for the question is seafloor spreading. Okay, and there was one more thing which I said while discussing Africa. I told something called Rift Valley, East African Rift Valley. How many of you remember?
Yes, sir. Remember, Africa
Right?
is splitting up to two pieces.
Yes, after millions years later, what I said is Africa, there will be two Africa, East Africa, Eastern Africa, and Western Africa. And the reason is because Africa is splitting into two pieces. I asked why, and I told you the answer lies somewhere else. Okay, the answer lies in plate tectonics theory. Okay, why Atlantic Ocean is becoming bigger day by day? Why Atlantic Ocean is expanding day by day? The answer is seafloor spreading. And why Africa is splitting into two parts? Answer lies in plate tectonics concept. Okay, both these concepts we'll see today itself. Right? Shall we move forward?
Yes.
Okay, right. Right, anyway. So this is the concept of seafloor spreading, which you already know. Mid-oceanic ridge, the Atlantic region, new land is created. The basaltic magma is fishing out. The basaltic magma is coming out every day, and so by the new floor is created every day. The land mass of the land mass of the ocean is expanding day by day. Okay, so this is what the seafloor spreading concept is. Okay, so this, I hope this picture explains it more clearly. This is the oceanic floor region, and this is the oceanic crust. This is the continental crust. If you see the thickness of the continents, it's more than the thickness of the oceanic crust. That's why there is a weakness, and even within the weakness, wherever the weakness is more, see, is it visible here? This place is thinner compared to the adjacent regions. Am I right?
Yes.
If you see the thickness of the oceanic floor here and here, and at the same time see the oceanic floor thickness here. So this is the weak spot, and in the weak spot, magma eruption starts to happen, thereby creating new land mass and thereby spreading seafloor on the adjacent side. Okay, so this is the mid-oceanic ridge where new seafloor is created every day, and this is where the old oceanic crust, okay, gets submerged inside the earth, thereby providing material source for the magma. Material source is the old oceanic crust. What is the heat source? What is the heat source?
Radioactive material.
radioactive material. Okay, so the old oceanic crust, once the submergence happens, or once the sinking of the old oceanic crust happens inside the magma, the old oceanic crust melts and become a part of the mantle itself. Okay, so basically the old oceanic crust is the material source for the new magma, and the radioactive materials present in the earth is the source for heat for melting this old oceanic crust. Okay, is it clear? Is it clear? Shall we move forward? Then how is sea is widening? Sir, new land is formed and old is sinking. Then how it expands? Okay. See, one thing is the sinking is not equal to the new land that is created. Okay, the sinking is less, the creation of new land is more. That's why it takes millions and millions years together to build or to expand. It's not a one-day process. It's not like one region, new land is created, like 10 kilos of new land is created, the other region, 10 kilos of old region is sinking. That's not the case. It is not equal, and also that's the reason why it takes millions and millions years to build. Okay, am I clear?
Yes, sir.
Okay. So now another question. You got the heat source, okay? You got the material source also, okay? And one more thing you should notice: the material source is not just the oceanic crust which is sinking, but also the continental crust region adjacent to the oceanic crust that also sinks along with it. Okay, that's why the mismatch is it, right? Sometimes the continental crust adjacent to the oceanic crust. Okay, if you see, this is the continental crust region, this is the oceanic crust region, and it is happening in the borders. So sometimes even the continental crust is sinking, which means more material is getting inside. So now my question is, you got the material source, you got the heat source, but where is the pressure? You need pressure, right? Where is the source for pressure? You understand my question?
So the collapsed area goes inside the lava, which
Not
gives the
getting you
pressure.
what?
The
Come again?
collapsed area which goes into the lava gives the pressure.
No, actually,
Like
that is not the source for pressure. That is the source for material. I'm asking about pressure. Convection current is not the pressure source. When temperature increases, pressure also increases. Isn't it the other side? Isn't it the other way? When pressure increases, temperature increases. Anyways, that's the
Yes, sir.
same
They are
concept only.
yes, sir. They are directly proportional. Like
It's directly proportional. Okay, so both the sides are correct, but that is not the case here. Temperature sometimes increase, sometimes gets maintained also. Yes, that is the answer. Anant, good. The water from the oceans, right? When the oceanic crust is sinking, water in the ocean also gets sink. Okay, it also seeps inside the magma, seeps inside the mantle, seeps inside the asthenosphere. Am I clear? Just like how in our pressure cooker, water is the source for the pressure, here also water is the source for pressure. Am I clear?
yes, sir.
Yes. and this is how the pressure is built inside, and that is why it is able to come out. Okay, so evidence for seafloor spreading. I hope you also know, I already know about the evidence for seafloor spreading. Yes, Biju. See, ocean is full of water, right? Ocean is full of water, and what happening here is the oceanic crust is sinking inside. That is, the old landmass is destroyed because of sinking inside. Okay, this is where the destruction is happening, the plate boundary region where destruction is happening. The oceanic crust sinks inside and becomes part of the mantle itself. While the oceanic crust is sinking, water also sinks along with it. Okay, some water also enters into mantle. Is it clear? And once the water enters into mantle, owing to the temperature, it becomes water vapor. And the more the water enters in, the more water vapor, the more water, the more water vapor, the more pressure, and they will be wandering around to find a weak spot. That's how pressure comes out. Only because of pressure, the explosion happens. Okay, so that is what with the water and pressure, right? So I hope it's clear now. Then evidence for seafloor spreading. You guys already know about the evidence. What are the evidences? What are the evidences? We already saw in paleomagnetism. We already saw so many. So tell me, what are the evidences? Good age difference. So the rocks on the either side of the oceanic ridges. Okay, so again the same diagram I have to draw. Eruption. The rocks on either side of the mid-oceanic ridges, okay, at equidistant from each other. That is what I said, 1 and 1, 2 and 2. Okay, so the rocks on either side of the oceanic ridges, equidistant from each other, were found to have similar properties of magnetism, right? This is one thing. Second thing is, which you said, age difference. Okay, age difference, 1 and 1 on the either side of same age, 2 and 2 on the either side equidistant from each other, same age, 3 and 3 equidistant from each other, same age. Is it clear? And one more thing is, 2 is older than 1, 3 is older than 2. Is it clear? Do you understand? One
Yes,
is
sir.
the magnetic properties, 2 is the age difference between 1, 2, 3, 4. The further you move away from the mid-oceanic ridge, the older the rocks are. The closer you come to the mid-oceanic ridges, the younger the rocks are. Is it clear? Age difference. Third is the rocks equidistant from each other on either side of the mid-oceanic ridges are of same age. That is one more thing. And the constituents, the materials, okay, the constituents of the rock 1 on either side, okay, they both have same constituents. 2 on both the sides, they have same constituents. But if you compare 1 and 2, they are made up of different constituents. Is it clear? So the constituents of the material, the age difference, the age gap, the rocks of the same age on both the sides equidistant from each other, and the magnetic properties all prove the evidence, all proves that sea floor is spreading. Is it clear? Am I clear?
Yes.
Okay. And one more thing is, after taking or after measuring the age of the oceanic crust, comparing it with the continental crust, oceanic crust are much younger than the continental crust. Which means what? If you compare oceanic crust along with the continental crust are much older than the oceanic crust, which means what?
So more spreading is happening in the oceanic ridge.
Oceanic crust is much younger because it is new. It's as simple as that. No need to complicate it. Okay. Oceanic crust is younger because it is created new. It is new one. That's why it is younger. Okay. So this is what, when you are asked to provide evidence for seafloor spreading, what you have to do is draw a diagram like this. Okay. Draw a simple diagram. You can mark mid-oceanic ridge, same age difference between 1 and 2. Okay, so you can provide points. First point, age difference. Second, magnetism. Third, constituents. Fourth, comparing continental floor with the oceanic floor. Okay, so you can quickly give answer. At the same time, you can draw diagram also. You can provide it in point also, so that it becomes easy for the person who's correcting your answer. And apart from that, it says that you have a good clarity in your subject. Okay, only when you have good clarity in the subject, you will be able to write in points. Only when you have good clarity in the subject, you will be able to say, you will be able to provide the answer crisp and precise to the questionnaire. Okay, so try to write answer in points, try to give diagrams, 2, 3, depending upon the demand of the question. Okay, am I clear? Shall we move forward?
Yes, sir.
Yes.
So this is a map, okay, which says there is something called ring of fire. Is it there? Ring of fire, right? Ring of fire means, if you see this region, so the dots means volcanic eruptions. Okay, the bigger the dots are, what do you understand if the dots are bigger? The bigger the dots are, come on, hot spots are. Even smaller dots means hot spots only. What do you understand from the term hotspot in this? Frequent eruption. Okay, good. More violent eruption, frequent eruption, more eruption. Okay, so this is what a hotspot is. Whereas the small dots represents the volcanic eruption, which means it could be something subtle, not violent. Okay, slow eruption, less frequent eruption. Okay, and one more thing is, deep earthquake zones are there, and also shallow earthquake zones are there. So the lighter dots, okay, the lighter dots that you are seeing here are shallow earthquake zones, right? And the dark regions that you are seeing here, okay, the dark regions are the deep earthquake zones. So basically, if you see the ring of fire, where is the ring of fire? Which place is that? Which part of the world is that? Which part of world is that?
So North Pacific Ocean region.
North Pacific Ocean. Okay, good. Not just North Pacific Ocean. If you see the entire Pacific, Ring. What do you mean by ring, first of all? What do you understand from the word ring? Ring means what?
Circle. Circle.
Circle, right? Ring is basically circle. Okay, a circle means not just North Pacific Ocean. It includes the entirety of Pacific Ocean. That is why it is called ring of fire. Fire, basically, you understand, it is volcanic eruption. So ring of fire means a ring-like structure that is created by continuous volcanic eruption. Is it clear?
Yes, sir.
Clear? Okay, good. So now tell me, where is this ring of fire? Which are all the countries that come under this ring of fire? Japan, good. Then United States of America, right? Japan, United States of America, the regions adjoining Japan, Malay region, right? East of Australia, then South America, Chile, Ecuador, right? Do you remember Cotopaxi, Chimborazo, Lake Titicaca? Do you remember it?
Yes, sir.
Cotopaxi, Chimborazo, Lake Titicaca, Lake Popo. From South America, Chile, Lake Titicaca. I hope you remember Lake Titicaca is the highest navigable lake in the world.
Yes, sir.
Yes? Okay, good. So, if you see this entire region, the concentration of volcanic eruption and all those spots which we saw in world map, now you should remember it. There was another question which I asked you when we were seeing Japan. Do you remember the question? Do you remember the question?
So why Japan faces so many earthquakes?
Exactly. Why Japan faces so many earthquakes? Why Japan is prone to earthquakes? Why Japan is facing volcanic eruption, earthquakes, tsunami? The reason is Japan is surrounded by deep earthquake zones. Japan is surrounded by volcanic eruption zones. Japan is surrounded by hotspot regions. So some of the hotspot region that you can see here is Yellowstone National Park of United States of America and Hawaii. Okay, these are some of the hotspot region, very important hotspot region. Okay, there is a type of volcanic eruption itself named after Hawaii, Hawaiian type. Okay, it is a different type. We have different types of volcanic eruption. Fissure eruption is there. Slow eruptions are there, depending upon the temperature, depending upon the material, the constituents of lava. So many different types of eruptions there. And Hawaii, Stromboli, different eruptions, right? So, anyways, that we'll see later in volcanic eruption. Now coming back here, this is what basically the seafloor spreading concept speaks about. So the distribution of earthquakes, volcanoes, okay, is concentrated along the mid-oceanic ridges, and the other belt is that where the destruction of old crust is happening, there is also concentration of earthquake and volcanoes are there. Am I clear? You understand? Okay. So this is the mid-oceanic ridge, right? This is the mid-oceanic ridge. what do you understand? What do you understand from this map? What do you understand from this mid-oceanic ridge? What is happening here? What is happening here? Come on, fast. We have plate tectonics yet to see. Come on, guys, don't waste time. Sea floor is spreading. New land is created. Eruption is happening. Volcanoes are there. Okay, so many things are there. But at the same time, this is a shallow earthquake zone, which means light tremors only you can see. Because eruption is happening, slow rate. Okay, but there are regions where deep earthquakes can be found. Is there any deep earthquake spot in India? Do we have any deep earthquake spot in India?
So what about Gujarat earthquake?
That is entirely different plate concept. We'll see that. Now I am asking about the deep earthquake spots in India. Northeast. Guys, are you all sleeping? If you don't answer, I'm going to sleep next. Am I audible? Do you understand my question? Did you understand my question? Then tell me. See the map and tell me. Question is there any deep earthquake zones in India? That is the question. Is there any deep earthquake zones in India? If so, where?
In the Himalayan belt.
Simple as that, right? In the Himalayan belt region, including the northwest region also. Which is not just northeastern region, the entire Himalayan belt. Okay, so the entire Himalayan belt, if you see, we have, it's known for deep earthquake zones. But why deep earthquake zones only in particular places? Like if you see the entire region of Chile comes under deep earthquake zone. The entire western side of United States. Okay, I hope you remember some of the places from the western region, right? Desert, Sonoran Desert, Mojave Desert. You remember? I told you to remember certain places there. Sonoran, Mojave, and right, Japan, all these regions. Okay, so why in certain places it is deep? Why in certain places it is shallow? Okay, we'll have the reasons in plate tectonics, right? So you know that continental drift theory, which spoke about continent drifting away from each other, and someone came up with the convection current theory. Who came up with convection current theory? Holmes. Alfred Wegener, then Holmes, then the seafloor. Okay, so as I said, plate tectonics solidified our knowledge about the movement of Earth. Okay, so in 1967, finally, Mackenzie and Parker are those two people who came up with this theory of plate tectonics, which solidified our entire knowledge about the movement of Earth. Right? So if you see the theory of plate tectonics, what they say is continental drift theory said continents are moving. Okay, continents are those solid that are moving on oceans, liquid buoyancy. Whereas plate tectonics said the convectional current breaks the continent into pieces or breaks the entire globe into pieces. And these pieces keeps on moving, wandering from one place to another because of the convection current theory. So what they said is it's not the continents that are drifting, but the plates that are underlying the continents are drifting away from each other. So if you see the plate, a plate means Earth's lithosphere. Okay, I hope you know about lithosphere. Lithosphere is the topmost layer of Earth. Earth has 3 layers. Lithosphere, that is crust, core, and mantle. Am I right? Earth has 3 layers, right? Crust, core, and mantle. Guys, isn't that right? Earth has 3 layers, crust, core, mantle, which is basic 6th standard, 7th standard text. Okay, so a plate or a lithosphere is those zone or the zone which consists of the crust along with the top mantle portion. Okay, the crust and the top mantle is called lithosphere. Okay, lithospheric plates. So the plates move from each other horizontally over a sphere called asthenosphere. So I already said about asthenosphere is right. What is an asthenosphere? I briefly said something about asthenosphere. What is asthenosphere? Good, semi-solid, semi-liquid, a plastic medium. Okay, so basically the lithosphere floats on the asthenosphere. Unlike the continental drift theory, which said the continents are floating on the ocean, the plate tectonics says that the lithospheric plates are floating on asthenosphere, and the convection current that is created on the mantle moves away the plates horizontally from each other, and the movement is happening on the lithosphere region, and the asthenosphere is where the plates are floating. Is it clear? Shall I move forward?
Yes, sir.
Plate tectonics is a very important concept. Why I say is, you can see that plate tectonics, or you can understand that plate tectonics is just one concept. Okay, but already I said plate tectonics encompasses many concepts within this. It's a solidification of our knowledge. Okay, and apart from that, plate tectonics describes, plate tectonics gives solutions, plate tectonics provides the answer why continents are formed, how continents are formed, how mountains are formed, why volcanic eruption is happening, why earthquake is there. Do you understand? So plate tectonics is just one concept that provides answer for volcanoes, earthquake, mountain formation, and continents moving. Is it clear? Is it clear? Shall I move forward? Good. So coming back here, plate tectonics. If you know the answer for plate tectonics, or if you know the concept of plate tectonics, and if there is a question about mountain building, all that you have to do is interchange the word plate tectonics into mountain. Answer is the same. If you know about plate tectonics and the question is about volcanic activity, just remove the word plate tectonics, put volcanic activity or volcanic eruption or volcanoes, you get the answer. Okay. Earthquake, remove plate tectonics and put earthquake there. Answer is the same. So earthquake, mountain building, seafloor spreading, and what else? One more thing I said. What is that? Earthquake, mountain building, volcanic eruption, seafloor spreading. Okay, yes. So continents moving, everything is the same. Plate tectonics is the concept. Plate tectonics is the formula behind this. Okay, only thing that you are going to do is just change the word, nothing else. Plate tectonics is a template where you can fit anything, mountains also, volcanoes also, seafloor spreading also. Just if you know plate tectonics, you can provide answer for all the concepts. Is it clear how Himalayas are formed? How Himalayas are formed? How Himalayas are formed?
Convergence of the plate.
Huh?
Plates converging.
Your voice is not. Your voice is very feeble. Kartika.
Convergence of plate.
Convergence of plate. Convergence of two plates happening. The Indo-Australian plate against the Eurasian plate, which is a plate tectonic concept, right? But we are speaking about mountain building. So the mountain building of Himalaya, the mountain building of Alps, happened because of the plate tectonic, or plate tectonics is the answer for the mountain building, right? If you speak about Atacama Desert, the entire Chile region, the mountainous region, the world's longest mountain range, which is the world's longest mountain range, which is the world's longest mountain range.
Andes.
And is created by, answer is again plate tectonics. Okay, so any mountains that you take, answer is plate tectonics, right? Same concept with this also, same concept with volcanic eruption also, earthquake also same. The question I asked for Japan, answer is here, right? So anyways, coming back to plate tectonics here. So as I said, plate means the lithospheric region. Lithosphere means crust and the upper mantle of the upper part of the mantle, that is the lithosphere. So the lithosphere, the size of lithosphere, the thickness of lithosphere varies from region to region. If you see the continental region, the thickest region are continents, as I already said. Okay, depending upon whether it is valley or a plain or a mountain, the continental area thickness is high, whereas the lithospheric plate of oceans, if you see, thickness is low. Okay, and the thickness varies from 5 kilometers to 100 kilometers in oceanic parts and 200 kilometers in continental regions. Okay, is it clear? Is it clear? Okay, good. So this is what basically a plate is. Right. Continent is thick, ocean is thin. That's clear, right? There's no confusion in that. No doubt in that, right? Okay, good. So now coming to the second part. Oceanic plates. Okay, oceanic plates are heavy compared to the continental plates, right? The continental plates thickness is high, whereas the oceanic plates, the weight is more, density is more. Okay, oceanic plates are more denser than the continental plates. Weight is also more in the oceanic plate because oceanic plates are made up of two materials. One is silica and the other one is Ma. What is Ma? People who belong to science background. What is Ma?
Manganese.
Manganese.
Sir, MA or NA?
Huh?
MA or NA?
Ma.
Manganese? No. Magnesium?
Okay. Huh. Right. So the continent is made up of two materials known as Sial. SiAl. Si is for silica. Al is for what?
Aluminium.
Huh?
Aluminium.
Not getting you what?
Aluminium.
Aluminium. Good. Okay. So if you see the continental crust, it is made up of two materials, that is Sial. Si and Al. We call it as Sial only. Okay. So Sial is silica and aluminium, whereas the oceanic plate is made up of Sima, that is silica and magnesium. Okay, Si-Ma. And people who from science background, you must be knowing this. Even if you don't know, no problem. I'm saying this. Magnesium is heavier than aluminium, right? Magnesium is heavier than aluminium. If you see the atomic weight, the mass of magnesium, it's more than the aluminium. So that's why the oceanic plates are denser than the continental plate. Okay, don't get confused because this is a recurrent question. It might come in UPSC. Even if it doesn't come in UPSC, no problem. You should know the difference between Sial and Sigma, and you should know the difference between the thickness and the density. Okay, which plate is more thick? Which plate is thicker? Continent or ocean?
Continent.
Continent.
Okay. Which plate is denser? Continent or ocean?
Ocean.
Ocean.
Ocean. Okay, so just the opposite. Right? Good. So, lithospheric plates. There are two types of lithospheric plates. One plate is called as continental plate. The other one is called as the oceanic plate. Okay, so there's no need to confuse here also. Continental plate means not just continent. You should understand that. If a plate is majorly comprises of a continent, then it is called continental plate. If a plate is majorly concentrated by water, then it is oceanic plate. Is it clear? Continental plate doesn't mean only continent. Oceanic plate doesn't mean only ocean. The majority. Okay, if the plate is majorly continent, it is continental plate. If the plate is majorly ocean, then it is oceanic plate. Is it clear?
Yes, sir.
And some plates both plays majority role. For example, Indo-Australian plate. Okay, both continent and ocean will be in an equal proportion. So that is a combined plate. Whereas some plates like Arabian plate is majorly continent, so it's a continental plate. And some plates like Pacific plate majorly comprises of ocean, so it is a Pacific oceanic plate. Okay, so is it clear? Shall we move forward?
Yes, sir.
Okay, and you know that the lithosphere plate, the movement of lithosphere plate creates earthquake. The movement of lithosphere plate makes mountain building process. The movement of earth plate creates new land. Okay, sea floor spreading, everything the same answer. The force you already know, convection current theory. Okay, and the rate of the plate movement, it differs from region to region. Okay, some places it's 2.5 centimeter per year, some places it's 15 centimeter per year. So that's not necessary for us. As far as you know that, as long as you know that the plate movement is different in different region, that is enough for us. Okay, so we have different types of plate. One is major tectonic plate groups. The other one is the minor tectonic plate groups. Okay, there are totally 7 major tectonic plates. Okay, only 7, not more than that. There are only 7 major tectonic plates. So someone kindly read what is there in the slide.
Sir, am I audible?
Yes.
Major tectonic plates. Antarctica and the surrounding oceanic plate.
Okay, good.
South American plate. Pacific plate. India, Australia, New Zealand plate. Africa with the Eastern Atlantic floor plate. Eurasia and the adjacent plate.
Okay, so these are the major tectonic plates in the world. There are only 7 major tectonic plates. Then minor tectonic plate groups. So someone kindly read this also. Guys, someone read this.
Cocos Plate between Central America and Pacific Plate, Nazca Plate between South America and Pacific Plate, Arabian Plate, mostly the South Arabian landmass, Philippine Plate between the Asiatic and Pacific Plate, Caroline Plate between the Philippine and the Indian Plate, north of New Guinea, Fiji Plate northeast of Australia, Turkish Plate, Asian Plate, Mediterranean region, Caribbean Plate, Juande Fuca Plate between Pacific and North American plates, Iranian Plate.
Okay. So how many minor plates are there? How many minor plates are there?
11.
No, actually, there are more minor plates available. We don't know exactly how many minor plates are there. Okay, so these are just important minor plates in the world. There are more minor plates available, which are even which till today we have not discovered some of the plates. Okay, so there are many more minor plates on the world, right? Am I clear? So I hope you can understand the difference between major and minor. Major means bigger in size, minor means smaller one, right? Is it clear? Shall we move forward? Yes. So this is what major and minor plates you can see here. Okay, the Eurasian plate, which comprises of Europe along with the oceanic regions surrounding Europe. You can see the Indian plate and the Indo-Australian plate. If you take India along with Australia, along with the Indian Ocean, is the Indo-Australian plate. These are the major plates, and if you see the minor plates, you can see Nazca Plate between South America and Pacific. Okay, Scotia Plate, Caribbean Plate. So you can see major and minor plates here. Okay, is it clear? Shall we move forward? So 540 million years ago, there is a globe map, right? There is a map of a globe. There is a globe 540 million years ago. Tell me, what are the continents you see there? What are the continents present there? Africa is there. Okay, so leave all other countries. Just to take African continent. Okay, see how 540 million years ago Africa was in the first globe, and see how the current Africa is. How different are these two Africas? Just in a span of 540 million years. So how different would be Africa after 540 million years? It wouldn't be the same. There could be several Africas, right? Okay. Then compare the India, the first globe and the last globe. Compare India. Where is India in the first globe?
Near the Africa.
Near Africa, right? Actually, it is a part of Africa itself. It was a part of Africa itself. Whereas now, it's a separate country, separate Indian subcontinent. It is a subcontinent, okay, which is converging on the Eurasian plate. Then it was a part of Africa. Now it is converging on a Eurasian plate. So who knows what happens after 540 million years later? After 540 million years, we don't know whether India will exist or not. Even if India exists, it would be crumbled and crushed along the side of Eurasian plate. Okay, is it clear?
Yes, sir.
And why? Why is it converging at one place? Why it is diverging from one place? Why it is going like a scrambled egg? One part in one time, the other part in another time. One continent at one place in 540 million years ago. Now it is a different place. Why? What is the reason? Plate movement, convection current. Right? So anyways, the force of nature is more than whatever scientific advancement and technological advancement that humans come up with. Consider 540 million years later, how different or how many scientific and technological advancement that humans would have created 540 million years later, I'm asking, right? The world would be entirely different, right? New scientific and technological advancement. We could have flying car, we have flying boots, right? We could have so many things. But think about the force of nature. Seeing what was there 540 million years before, are we even sure that Earth will remain? Are we even sure that Earth will be there? Or the continents as we see today will exist? Or humans as we see today will exist after 540 million years? Seeing the force of the nature. This is the force of nature. Seeing how different it is in a span of 540 million years. The next 540 million years, no matter what kind of advancement that human race invents, no matter how many scientific, technological advancement and upgradation that humans come up with, it is going to be of no match when you compare it with the force of nature. Am I right? Am I right?
So
Is it correct? Yes. So now my question would be about the change in climate. So after seeing so many things, now tell me guys, the climate change, is it a natural phenomenon or a human-made phenomenon? Is it a natural phenomenon or a human-made phenomenon?
so presently humans are contributing more in the climate change.
Presently humans are contributed. Okay. Is it a natural or a human-made? Is it natural or anthropogenic? Both. The simple answer is both only. Okay. Climate change is an ever-occurring phenomenon. Whether humans are there or not, even before humans, climate change happened. Even during the period of the advanced human race civilization, climate change is happening. Even after we are long gone, human race is entirely wiped out of the face of the earth, climate change will happen. Climate change will keep on happening. Climate change is one phenomenon that is ever occurring, and there's no way that humans can stop it. Yes, we have aggravated. Okay, yes, we have aggravated the climate change by influxing more carbon dioxide into the atmosphere, by swelling up the seas, okay, by swelling up the oceans, by disturbing the isostasy of the earth. We have created so many so many horrible things to the environment. But even if we didn't do anything, climate change is bound to occur. Climate change is bound to occur whether you do or do not, no matter what it is. Right? So if someone says climate change is only because of humans, no, that is not the case. Nature is stronger than any human. Nature, the force of nature is stronger than any human force, no matter what the scientific and technological advancement is. Only with scientific and technological advancement, we are able to procure some comfort. Apart from procuring some comfort, we are not playing any major role here. Right? Anyways, so you know the evidences of plate tectonics already, right? What are the evidences? Come on, what are the evidences? We already saw so many evidences. You already know. What are the evidences? What are the evidences, guys? Paleomagnetism. Right. Then.
Age difference of rocks.
Yes, age difference of rocks. Age difference of rocks equidistant to the either side of the seafloor spreading, distribution of earthquakes. Then older rocks on the continent while younger rocks are there in the oceanic floor. Right? Rocks are younger as we move towards the mid-oceanic ridge. Rocks are older when you move further away from the mid-oceanic ridge. Distribution of fossils. And one important thing which we didn't see is that gravitational anomaly. What is the meaning of anomaly? I hope many of you know about this word, anomaly. What is the meaning of anomaly? What is anomaly?
Something that's not supposed to happen,
Right.
but it happened.
Anomalies, yes, good. Anomalies is something different, something that is not supposed to happen, or something that happened is out of what our understanding is. Right. So gravitational anomaly basically means the presence of gravity or the absence of gravity or the less gravity or the more gravity that is available at certain regions are called gravitational anomaly. Okay, presence, absence, less, more of gravity. Okay, for example, in the borders of Indonesia oceanic trenches, you can see gravity anomaly. Okay, so this describes or this gives the proof that plates are present, that convergence are happening, destructions are happening, because gravity anomaly gives a clear indication that surface created and destroyed at certain places have contributed to large gravitational anomalies. Okay, and as you already know, earthquake and distribution of volcanoes all throughout the world is also another thing which gives the evidence for plate tectonics, right? Okay, now, now if I start anything new, I won't be able to complete. So what we'll do is we'll compare and contrast continental drift theory with the plate tectonics. Okay, shall we? Yes, good. So I hope you the significance of plate tectonics, anyways, you know already. Okay, all the major landforms that we see today are formed because of the plate tectonics. Okay, the new minerals that comes from the core comes from the magmatic eruption, right? The other day when we were discussing, I asked you if the heavy metals settle down, settle below, that means we should see heavy metals only near the core, only in the core. And why are we seeing in the crust also, or why are we seeing in the surface also? You guys gave me one answer. The answer is the magmatic eruption, which is here. Okay, new minerals. And apart from that, the supercooling process also, it is also there. And valuable minerals like copper, uranium, okay, are found near plate boundaries. Okay, so you can pinpoint the regions where new valuable minerals, new materials can be found. That is one thing. Okay, so by knowing plate tectonics, by knowing the significance and the movement of plate tectonics, we can predict the future, we can predict the land masses, we can predict how different the earth would be, how different the continents and the ocean spread would be after 500 million years here, after 600 million years. Okay, by the extrapolation, we can do that. And apart from that, you know, as I already said, Africa would become two Africas. North Atlantic Ocean will become the largest ocean in the world. Australia will move closer to Asia, right? South America will get separated from North America. So many things are bound to happen owing to the plate tectonics. Okay, now we'll compare and contrast the continental drift along with the plate tectonics. So first, comparison. Tell me, guys. Compare plate tectonics with the continental drift. Is there any comparison point? Okay, I'll give you topics on which you can discuss. Okay. Author or the scientist behind continental drift theory, what is his name?
Alfred Wegener.
Good. And for plate tectonics? Mackenzie and Parker. Okay. Anyways, now just know these names. It will be helpful for you in the examination. Okay, because once you provide these examples, once you provide these certain facts, the person who's going to correct your paper will come to know that you have prepared, that you know the concept. Okay, that's why certain facts are important, right? Then, what is basically the continental drift theory is about? Movement of continent. Good. And what is plate tectonics? What is the basic theory of plate tectonics? Continental drift speaks about movements of continents. Good, very good. So if you see the theory of continental drift, it speaks about the movement of continents only. It never speaks about ocean, whereas the plate tectonics speaks about both the movement of oceans as well as the continents through the movement of lithospheric plates. Okay, there's a difference, right? And what is the force that drives continental drift theory? What are the forces? Buoyancy, tidal, polar fleeing, centrifugal, right? Good. And what is the force, or what are the forces that drives plate tectonics? Convergent current, convection current, right? Good. What are the evidences provided by Alfred Wegener? What are the evidences? Tillite, fossils, right? Tillite, fossils, rocks of same age, jigsaw fitting, polar wandering. Okay, botanical. Good. What are the evidences provided by plate tectonics? Evidences provided by plate tectonics. Paleomagnetic properties, age difference, distribution of earthquake and volcanoes. Okay, good. Yes, gravitational and
Mountain formations.
yes, mountain formations. Okay, good. So now seafloor spreading, right? Who's the person responsible for the seafloor spreading? I mean, the concept put forward by which person? Seafloor spreading. No, 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 no. It's not Holmes. Arthur Holmes explained about convection current theory, not seafloor spreading. Continental drift theory came in the year 1920. Seafloor spreading concept came in the 1940s. Convectional current theory came in the 1930s. Plate tectonics came in the year 1968. Right? So 4 people are involved at 4 different periods. First is Alfred Wegener in 1922 in 1920s. Then Arthur Holmes in 1930s, where he spoke about convectional current. And in 1940, it is seafloor spreading by Harry Hess. Okay, and finally, the plate tectonics, which solidified all these concepts, happened in 1967, 1968, that is late 1960s. Okay, so the entire period, if you see, everything happened in a span of 50 years, starting from 1920, and by the end of 1960s, everything happened. Okay, first is continental drift, second is convection current, third is continental drift, third is seafloor spread, and fourth is plate tectonics, right? And what is the theory behind seafloor spreading? Oceanic plates movement, right? Good. So the theory is, first is continental drift. It speaks about movement of continent only. Seafloor spreading speaks about the movement of oceanic plate only. Whereas plate tectonics, it merged both the concepts through the plate concept, through the concept of lithospheric plate. Okay, so what is the force behind the seafloor spreading? Convectional current. What are the evidences provided by Harry Hess? Force provided by Harry Hess. Evidences provided by Harry Hess. Paleomagnetism, then age difference. Okay, also you can include the distribution of volcanoes. Okay, divergent plate boundary, obviously it's a divergent place where volcanoes are produced, new land is created, which means volcanic activity also can be included. And obviously when volcanic activity is there, earthquake is also there. So the distribution of earthquake and volcano can also be taken as evidence for the seafloor. Okay, right. So what are the drawbacks for the continental drift theory? Drawbacks of continental drift theory.
It only speaks about movement of continents.
Speaks only the movement of continents, yes. And the evidence, some of the evidence are illogical, and the forces provided by Alfred Wegener are totally illogical. Okay, but is there any drawbacks for plate tectonics? Yes, good. Continents floating over ocean, the buoyancy, all are illogical in nature. Okay, so there is no drawback for plate tectonics as such. And what about seafloor spreading? Is there any drawbacks for seafloor spreading? Drawbacks of seafloor spreading?
It doesn't explain the movement of continental plates.
Yes, it spoke only about oceanic plate, so it did not speak about the continental plates. That's the only drawback you can see. Continental drift theory was discarded, whereas seafloor has been accepted, but it doesn't paint the complete picture of plate movements. Whereas the plate tectonics, it's the most widely accepted form of earth movement. Okay, and apart from that, continental drift theory paved the way for the development of convection current theory, which happened which happened a decade later, that is 10 years later. And the seafloor spreading concept, convection current theory, which happened 10 years, 20 years later. It's because of the continental drift theory, and that is the reason why continental drift theory is very important for us. Okay, and after that, the seafloor spreading, which gave the evolution of plate tectonics. So seafloor spreading also paved a way for the development of plate tectonics. Okay, so is it clear? Am I clear? Shall we move forward? I think we cannot move forward. So if I start something new today, I won't be able to complete. So what we'll do is tomorrow we'll see about different boundary movements. Okay, that is the convergent boundary movement, divergent plate boundary movement. Okay, so the interactions of plates, oceanic plate, continental plate, and how they are converging, and what happens when they are converging, what is created when they are converging, or what is destructed when they are converging. And the same case goes with the divergent plate boundary also. And there is one more plate boundary which is called transform plate boundary. So we'll see the movements of plates tomorrow, and after completing that, so now I would like to ask you guys the suggestion. So what should I take next? Do you want me to move little to climatology, or should I continue with this geomorphology itself? Should I go with geomorphology, or should I go a little climatology and come back? Because
Sorry.
already the basics are taken, the latitudes, longitudes, certain movements, earth movement, the basics I have taken. And if I have to go to climatology, we have to discuss about pressure system, the pressure belts of the world, how the wind is formed, why it is moving from one region to another region, how pressure is related, okay, and what are the different spheres within the Earth's atmosphere. Okay, those basic things about climatology we are yet to see. Okay, the basics about geomorphology, which we already saw, that is the continental drift theory, plate tectonics, seafloor spreading, paleomagnetism. These are the basic things for geomorphology. So should I go in a non-linear fashion, like basics of geomorphology, basics of climatology, then advanced things about geomorphology, advanced about climatology, and also we have oceanography, basic about oceanography, and the advanced about oceanography, or should I go in a linear fashion, complete geomorphology, then oceanography, then climatology? Which way do you want me to go? It's entirely about your suggestion. However you want me to go, I'll do that way. But remember one thing, geomorphology is not that important for UPSC. So no matter whether I am going taking in which format, whichever format you want, non-linear fashion or linear fashion, I'll complete geomorphology as soon as possible. Okay, I won't waste time on geomorphology, because UPSC for the past 10-15 years they are not concentrating on geomorphology. The questions are always coming from climatology and Indian geography. So I will spend more time on climatology and Indian geography rather than geomorphology. Is it clear? Because no matter how many classes I spend on geomorphology, it's going to be of waste. And it's not going to help you in the exam also. It's not going to be helpful in any other format. Okay, also geomorphology is one vast subject and consists of majorly fact-oriented, factoid-oriented subject. So it's going to waste your time, my time, and it's not going to be helpful in the UPSC exam also. And I won't be able to cover the entire geomorphology because it's one vast region. Okay, that I want to make sure, right? My concentration will be on climatology and Indian geography, because that's what going to help you. So it's up to you totally now. Decide whether I should go in non-linear way or linear way. Whichever you say, I'll do that. Climatology. Okay, some people are saying climatology, some people are saying geomorphology. Right. Okay. So what we are going to see, yet we have to see in geomorphology is that, as I already said, we will see the different plate that's what plate interactions with each other, and after the plate is completed, we'll look into earthquake, mountain formation, those small details about it, and then we'll go to different topography, the depositional topography, glacial topography, karst topography, different landforms are there. We'll brush through that very quickly, and after that we'll look into the Earth's different layer, and after that we'll complete it with this sedimentary rock formation, metamorphic rock formation, and apart from that there is nothing much. Volcanic eruption, that's it. Okay, I'll complete it very quickly, then we'll move on to climatology. So that's how we are going to do it. Okay, right. Okay then. So tomorrow, anyways, we'll complete the plate tectonics. Okay, guys. Do you guys have any doubt? Any doubts? Any doubts?
Sir, I have a doubt.
Yes.
After writing the answer in UPSC paper, what to do with the blank page?
Which blank page?
UPSC, you said that UPSC provide 2 pages for writing 150 words.
Yes.
After writing the answer in points, we
Okay.
may have a blank area.
Yes. Just strike it out.
Strike
it out. So
Okay, sir.
for example, if you will be given 2 pages for a 10-mark question, and if you are able to write only 1.5 pages, just strike the remaining. Just strike out the remaining half page.
Okay, sir.
Okay. Right. Anything else? Okay, then. Thank you all. Have a good day. Thank you, guys. Thank you.